On example number 3, we've got, oh, sorry, I guess this is a new video. So this is still section where we at 3.1, part 2, integrating by parts. So we're on to example number 3. So we've got a particle that moves along a straight line, has velocity v of t equals t squared e to the negative 4t meters per second after t seconds. How many meters will it travel during the first t seconds? So got a real life problem here. So let's write down a couple of things that we know about velocity, distance equations, and acceleration. So back when we were working with derivatives, we started off with a distance equation. We could take a distance equation and take the derivative of that, and that would give us velocity. So the first derivative was velocity. The second derivative was acceleration. So now that we're doing integrals, we can work our way back up to find our distance equation. So they are starting us off here at velocity. So they're giving us a velocity equation, and they want to know what the distance is. So one thing that we're going to use, we're going to be able to find a c value. Most problems when we have, a real life problem here, scenario, we can find what that c value is. So we want to know how far did it travel during the first t seconds. Well, we are going to assume that at time equals 0, that this particle, this particle at d of 0 has traveled a distance of 0. Okay, so at time equals t equals 0, the distance that is traveled is 0 also. So we're going to use that later on to find our c value. All right, and so our equation is t squared times e to the negative 4t. So we have an algebraic equation before an exponential equation, but I can tell you right now, I can see that this t squared is going to cause us trouble. And you will see why in just a minute. So let's go ahead and choose our u and our v. I'm going to need lots of room for this, so I'm trying to figure out where to write stuff. I'll start off clear up here. So let's say we've got u is equal to t squared, and dv is equal to e to the negative 4t. Okay, so now du is equal to 2t dt, and v is equal to negative 1/4 e to the negative, oh dear, no, don't do that to me. Oh crap. I'll have to pause for a second. Okay, so what did we end off here? So we've got negative 1/4 e to the negative 4t is our v value. So our integral is going to equal u times v. So we've got u, which is t squared, v, which is negative 1/4 e to the negative 4t. So let's write that how we're going to want it first. So negative 1/4, then t squared, then e to the negative 4t. I'm trying to take some shortcuts here because this is a long one. Minus the integral of v du. So let's take a shortcut here too. So we're going to take the integral of v, so it's going to make a plus 1/4 out in front. Then what is du is also 2, so we can put that 2 out in front also, times the integral of e to the negative 4t times t times dt. All right, so this is where our problem is. We still have where we're going to take the integral right here. This is still a product of two functions, so we still cannot integrate yet. So what we're going to do is we are going to do the differentiate integral by parts. It's getting too late at night. Integration by parts again. So now we're going to take out just this part. Let's do this in a different color. We're going to take out just the integral. I'm going to leave the 2/4 out in front of there. So in the end, we're going to have to come back and pick up all of this once we're done. And we're just taking this integral right here. So the integral of e actually, let's write it nicer. So t e to the negative 4t dt. Okay, and we need to pick a u. So we want to say u is equal to t. dv is equal to everything else. So e to the negative 4t dt. So then du equals 1, or just dt. And then the integral of dv is equal to negative 1/4 e to the negative 4t. Alright, so here we go again. So now all of this is equal to u, which is t, times v. I'm going to put that all together as 1 here. So negative 1/4 t e to the negative 4t minus the integral of v du. So I'm going to pull out that negative 1/4 out in front of my integral. Negative 1/4. Now e to the negative 4t dt. Okay, so keep going. That equals negative 1/4 t e to the negative 4t plus 1/4 times the integral of e to the negative 4t, which is negative 1/4 times e to the negative 4t plus c. Alright, let's see. I don't think can I write that one more time? Maybe. We'll try. Negative 1/4 t e to the negative 4t minus 1/16 e to the negative 4t plus c. Alright, so remember that's just our second part of our equation up here in blue. So let's go back up here where we circled in red and rewrite our full answer. So this is our distance equation. Our distance in terms of d. We'd have room for one more line still. So our distance in terms of t is equal to negative 1/4 t squared e to the negative 4t plus 1/2 times all of this down here. So negative 1/4 t e to the negative 4t minus 1/16 e to the negative 4t plus c. Okay, now can we simplify a little bit more here? I'm going to do that one more time. So we're going to get negative 1/4 t squared e to the negative 4t, oops, minus, a little bit of minus there, minus 1/8 t e to the negative 4t minus 1/32 e to the negative 4t plus c. Alright, now back up here where we said d of 0 equals 0. Let's plug that in right here and see what we get. So I'm going to come right here in this open spot and solve for c. So if we have d of 0, we're going to plug 0 in for t, all of this. Well, what's going to happen, this first is going to be just 0. Second term is going to be just 0. This term right here, e to the 0, would be 1. So we'd end up with just negative 1/32 plus c equals 0. Therefore, c equals 1/32. Now we know what c is. I would have a pretty nice quadratic equation if I factored an e to the negative 4t out of all of that. Let's factor out the negative 2. So I have a fairly nice looking answer. D of t is equal to negative e to the negative 4t of 1/4 t squared plus 1/8 t plus 1 over 32 plus 1 over 32 for our constant. And that's our final answer. There's obviously other ways that you could write that. You could factor out a 1/4 as well with that e. You could put the 1 over 32 out in front so you don't have that negative out in front. A lot of different ways to write this equation, but that should get you through the MyOpenMath with a nice answer, and an answer that I will like to see on your homework assignment as well and your test.